Shemai, and welcome to session 2 of the Geography GCSE revision sessions this October. They're run by myself, Mr. Miles Herman. I'm a geography teacher in Ysgol Gyfun Gwenty's Coed in Newport. And today we will be looking at water resources and their management, which comes under theme 6.3 of the GCSE syllabus, which it will be examined through examination in the Unit 2 exam, which will be assessed in Year 11, the end of Year 11, just like the Unit 1 exam, but this exam will come 2 weeks after the first exam. And this is content that you've probably studied in Year 11. So the contents of today's session, we'll be looking at how and why is the demand for water changing and are water resources managed in a sustainable way. We'll be looking at these two aspects through looking at the contents and some are case studies that I use in the classroom, but you don't necessarily need to use these case studies. And secondly, we'll be looking at possible questions that could come up in the exam paper, and looking at some examples and a success criteria of how and why those got certain marks, for example. So if I had to move this, so hopefully at the end of the first half of the session, we'll be able to answer these 4 questions. Why do you think we use more water than ever? What kind of countries use the least amount of water and why? What countries use the most amount of water and why? And what does the future look like in terms of water security? Why? However, it's important for us now to look at why the demand for water is changing. Well, there's worldwide trends in water use, and we're going to look at a graph in a second. But global water use in general has been increasing, and there's 2 main reasons for this. One of which is the increase in population. More people means that more people need water for drinking, hygiene, cooking, cleaning. And also, water is needed, most importantly, to produce the food that we eat and the goods that we use. Secondly, then, economic development. With more and more countries developing and becoming high-income countries, and there are less low-income countries, this means that the water use and the demand for water use will continue to increase. There's some terms that we do need to consider when we look at this unit, and we need to think about the fact that WJC could ask us to define some of these terms, and we would need to give a definition. So here are some definitions of terms that we need to consider when revising this unit. So water use is the first one. How much water and how water is used, how much water there is and how much water there's used. Gross national product per capita, which is GNP. Sorry, this is IGC there. That's well shortened. So it's GNP. So average country income. Another term is gross national product per capita. So high GNP is a high income country, low GNP is a low income country. Virtual water, this means the total amount of water that has been used to grow our food and make our clothes. Water footprint, our personal water use, litres a day it's measured in. Over abstraction, when water is withdrawn at a faster rate than replenishment, leading to a reduction in the amount of water storage. This is from water stores below ground. Irrigation and irrigate, a system of getting water to an area for agriculture. We have here reservoir, large stores of water on the surface of the earth, usually in the form of dams. Water security, to ensure that sufficient water supplies are available at all times. Water surplus, abundance of water in an area. Water scarcity, not enough water in an area. Relief rainfall, rainfall that is formed due to the high ground and mountains. Now, if you would like to revise this, there is a session on this from 2021 on theme 5. Sustainable development, that meets the requirements of the present without impairing the ability of future nations. Future generations, I should say. Aquifers, rocks in the ground that can hold large amounts of water, and agriculture, another word for farming. Okay, so here's the graph that I was speaking about water consumption from 1900 to 2025. This is across the world and also shows different continents as well. So we can see the general trend here for water consumption is an increase. Then we can see all the different continents as well. And we can see that, for example, continents such as Asia here has seen an exponential increase of water consumption in billions meter cube. So a possible question that we could get in the examination would be describe trends seen in the graph. Now, a possible success criteria of things that you could suggest would be, is there a common pattern? Is there a general trend that we can see? Is generally what happening is an increase or a decrease? Is there a certain highlight or low point? So is there a maximum and minimum point that we can see that's worthy of telling? Can we give data to back up our point? And is there an exception that we think that doesn't follow the pattern? So if you want to give this question a try at home, and press pause here and use the data seen in the graph to answer the question, describe trends in the graph. However, when we look at the graph, it's important to maybe note, why does an average family in America use 1,300 litres of water, where an average family in Africa uses as little as 22 litres of water a day? So we can see comparable differences between some continents, and we're going to look at why the reason is for this in a second. However, we could also have a question like this, and as seen on this graph, there is the question here could ask you something like, describe the relationship between GNP per capita. So as we can see here, the GNP, so how much on average do people earn, and the water use per capita, which is on this axis here. So do we see a negative correlation? So a negative correlation would look like this, it would be going down, or do we see a positive correlation? So as one increases, the other increases. Well, what we can see is generally we can see a positive correlation. However, there are some exceptions to the rule, and that you could possibly point these out in the answer as well, in addition to saying there's a positive correlation. And maybe say what example goes with this positive correlation, and what would be the GNP, and what is the water use per capita as well. So if you'd like to give this question a try at home, you can go for it. Okay, generally water use does vary between countries, within regions, and also within continents. In sub-Saharan Africa, for example, people living in urban areas are more likely to have safe drinking water supply compared to living in rural areas. Now, if you saw my session last week, and if you'd like to revise global cities, that's also on the Cadlam Cymru website. And I spoke about one global city in particular in the country of Ethiopia, which is Addis Ababa, and that sort of conforms with the trend that in urban areas, people flock to these urban areas to migrate to live there because of opportunities that they hold, mainly for jobs and for money, for better education for their children, better healthcare, but access to water and sanitation is also another reason why. And because that population is greater, it means that there's better access on the whole, so they don't have to travel distances for safe drinking water, which does happen in rural areas, especially in this region, in the Sahel, where there is a huge water scarcity. If you also like to read up more about the Sahel and what's happening to the Sahel, please watch one of my sessions from last term. That was, I think it was the 4th session, which is on environmental challenges, which talks about the Great Green Wall project that they're doing in order to go against this trend of sort of arid and desertification. Okay, water footprint. What is water footprint? Well, on the map, it shows water footprint. So as we have already looked at what the term of water footprint is, well, it's the personal use of water, and this is measured in litres. And it's shown over different countries in the world. Now you could get a question, describe the pattern that can be seen in the map. Now, what map is this? Some of you are probably asking. Now, I would like you to pause the video and try and think of what map is shown on the screen. Now, if you were thinking choropleth map, you are correct. So this is a choropleth map. And what's good about a choropleth map? That it shows the data with use of colours, and the data is shown on the map on the area shown here. Now, It should be done in gradual colour, so that it's not in completely different colours, so it's not hard to read, and that is being seen in this choropleth map here. So you could get a question just generally on use of choropleth maps and why it would be good to use in this circumstance. However, if you could think of an answer, describe the pattern that can be seen in the graph, you could go ahead and answer that at home. Now, another question I thought that you could have, in addition to having a map like this, would be suggest reasons for this pattern. Now, why would we see a possible pattern that in these countries, such as USA, we can see in Brazil, we can see in Australia. So in some countries in particular, there's a pattern where there is excessive water footprint. Well, these are some of the reasons I've given on the bottom of the screen. So the locations of the countries, are they landlocked? Are they close to water sources? That could be one reason why they've got a high or low footprint. What's the climate of the countries like? Do they suffer from droughts and then therefore don't have enough water to have a large footprint, possibly? Wealth of the country, if it's a low-income country, a hick or a lick, low-income country, that would have an impact as well on the amount of water that they'd use. Industry, what sort of jobs are available in the country? Does this mean that there's more water than others? And are there any anomalies or surprises on the map? And could you try to explain them? Are there any countries in particular you think, oh, that's interesting? Why would there be a water as a high or low footprint in this country or this area? Okay, water footprint. So as we know, it's our personal water consumption in litres a day. It's measured how much water used for drinking, cooking, washing, and how much there is for production of the food that we eat and the goods that we use. The water footprint tells us how much water is used by a person individually in a country or the wider world. 70% of the water we use is for food production, 20% is in industry, and 10% only is for houses in our homes. So in agriculture, most water is used for irrigation. Now we know the term irrigation is water used for agriculture farming. Industry uses large quantities of manufacturing and cooling processes. In the home, water is used in toilets, washing machines, showers, baths. A large volume of water is lost through evaporation and leaks in dams as well. And that might have an impact too. Water security, another essential term that we need to learn, ensuring that sufficient water is available at all times. And this means that there is enough safe and affordable water to keep people healthy, that there's enough water available for agriculture, industry, and energy. Ecosystems supply our water, wetlands are protected. For example, the wetlands that are in Newport, and that people are protected from water-related hazards such as dryness that can be seen and desertification that can be seen in the Sahel region in particular. Ensuring sufficient water supplies of fresh water is crucial to provide drinking water, water to grow crops, and to the supply industry. Water scarcity can mean that health and the economy will suffer. Therefore, water security is important for every country. How some countries would have a water surplus, where they have more than enough water for an area, which is greater to the demand that they needed, where some have a water shortage, where it means the supply is less than the demand. So two essential terms for us to remember there, because we might be asked to define what water scarcity means. Okay, so what effect does an increase in consumerism, or what effects can we see to be because of a water scarcity or demand for water? Now, there are three possible ones that we've put here. So what effect does an increase in population have on water security and demand for water? Well, if there's more people, more water needed for drinking, food, consumerism, also for washing, for industry. So to bear that in mind. What effect does an increase in consumerism, so us buying, using items and things that we use every day, have on water security and demand for water? Well, for example, clothing, fast fashion. And for example, I put a pair of jeans here. It's 7,600 litres in order to create one pair of jeans. So there's a huge impact on water security due to consumerism. What does effect does a change in agriculture have on water security and demand? Well, food and avocado, for example, are hugely popular in the Western world, and avocados take 272 litres of fresh water to grow simply one avocado. Maybe for you to think at home, which of the factors above do you believe have the greatest impact on the security or demand for water? Well, you can think about this further. with this exam question that came up in the 2023 WJC exam. Well, this could come up in another capacity, we don't know, so it's possible we should really examine this now and take the opportunity to look at an example. So here's the question. Three factors that play an increase for the demand for water, which are population growth, growth of consumerism, agricultural change. Choose the factor which, in your opinion, has had the greatest impact. Justify your choice, and you will also get 3 marks here for your expression of your writing. Now, you're not to only speak about one factor you would need to speak about all 3 and then come to a conclusion of why you think that your factor is the most important. So here is an example of a possible answer. In my opinion, I believe that population growth has had the biggest impact on the increase in water demand, because as growth increases, demand for more and agriculture increases, as well as demand for clothes and goods also increases, so it has an impact on all aspects of life. As the demand for food increases, the water needed to grow, it also increases as more crops are needed. Also, a large amount of water is used in production of clothes, especially a pair of jeans. It goes without saying that a population growth increase, the number of showers, toilets and baths increase, which also affects water use. Despite this, a change in agriculture, such as production and crop cultivation, has a devastating effect on the environment, such as fertilizers that can get into the water supply and contaminate it. Also, the increase in purchasing has a surprising effect, as many machines use water as a means of cooling during production. Okay, lots of good aspects about this answer. I would score it a 5 out of 8 and maybe a 2 or 3 in terms of accuracy of writing. And now parts of this made sense, but it did sort of go on and it lost sort of fluidity during the end, because it felt just more like a list. I put here, generally a good analysis that has been elaborated. So ideas were sort of elaborated. We can see here, for example, where it says because as well, for example. Now, this is the connectors that you need to use in these 8-mark questions. They've spoken about every factor, and there was general linguistic accuracy. However, targets and things to think of, examples. Now, population growth. Well, what populations, what countries, what continents are growing more rapidly? You could sort of speak about urban areas, possibly. What are the implications for a developing country, possibly? Consumerism. I don't feel like that was sort of embellished on properly. There was a note of about a pair of jeans. I did like that. We could have probably said how much water that one pair of jeans, for example, would needs, and also that consumerism is growing not only in high income countries but also in low income countries as the whole world is developing. Again, continents that this may vary, they could have noted on this, but generally 5 out of 8 is what I would have scored this example. Okay, we're now looking at part 2, are water resources managed in a sustainable way? Now, this map shows millions of litres available per person, and how much water will be available to each person by 2070. So some parts of the world here are more risk of water shortages and scarcity than others. And as the world population increases, there's going to be more pressure for water. Where's all this water coming from? So strategies to manage water supply. Well, there's reservoir building, provide a large supply of water throughout the year for domestic and agricultural use. Water transfer plans, so they can transfer one area of where there's a water surplus to an area where there's a deficit, and this can take place through pipes and canals. Thirdly, then, groundwater extraction, so they can take from aquifers, from water stores below ground, extracting water from underground in the crux of the soil, sand and rocks. Desalination station, they can remove the salt from the seawater to make it safe to drink, but this is an expensive process and does require a lot of energy in order to do so. Water conservation, so people have water meters, dual flush toilets possibly, to a way to conserve water better, and also the use of grey water, so reusing water that's already been used before, for example, flushing toilets that can be reused. Essentially, we need more water. So one strategy is the Lesotho Highland Water Project. It's a top-down project, and we need to know that this is a top-down project whereby a project is run by the government. and it is used in communities. And it's an international water transfer scheme. So what it is a case study that looks at water conflict between two countries, South Africa and Lesotho, and a project that's sort of done in order to alleviate this issue. Now, Lesotho has suffered from drought. However, it does have a lot of mountainous regions that do receive a lot of high rainfall. And obviously it's landlocked within South Africa. So the solution of the drought and the desertification and the lack of water and the water deficit in some areas was piping transfer water to the south. So looking further at this water transfer scheme then, Lesotho Highlands Water Project is an example of a large-scale water transfer scheme. Dams collect water in mountainous areas to supply water of deficit in neighbouring country of South Africa. It is the largest water transfer scheme in Africa, diverting 40% of the water in the Senk River Basin in Lesotho to the Vaal River system of the Orange Free State of South Africa. Via 200 kilometres of tunnel systems. The first phase of the project started in 1984. Two dams, the Katse and the Mahal, were built. A second phase of construction began, the Polhali Dam. The new dam will generate 1,000 megawatts of electricity for Lesotho, and phase 2 will cost 1 billion, and it has actually been completed in 2020. So what are the advantages and disadvantages? Sorry that this is sort of skewed. I'm going to press escape here and move this over now. Sorry about this. Okay. Okay, so Lesotho is one of the world's poorest countries. It has a few natural resources, so selling water to South Africa provides 75% of Lesotho's income. However, many people in Lesotho do not have access to improved water sources. A new dam in the Metlong Dam is being constructed to supply lowland areas in Lesotho with water. The project is costing 31.80 million US dollars, money that Lesotho has borrowed and will have to pay back. The dam is finished and the pipes and tunnels to transfer the water should be completed by 2020, which they have. Until then, many people in rural areas of Lesotho will spend many hours fetching and carrying water. They will still actually have to go and collect it. So within this, could you possibly think of a table of advantages and disadvantages of this project? Well, these possibly some that you could consider as well. 20,000 new jobs have been created. Percentage of people in South Africa with access to safe water had actually risen from 83 to 87. Lesotho government is receiving money from South Africa. This makes for 75% of the country's income. The dams provided HEP as well as water. Disadvantages led to an increase of AIDS and alcoholism. Bills went up before the improvements. People in Lesotho still have poor access to water, and 20,000 people were forced to move after the first dam was built. Okay, a possible exam question that you could go ahead now and answer is referring to an example that you've studied, describe it, and explain how a water management plan affects two countries. Now, we know this, Lesotho and South Africa, and we would say the Lesotho, South Africa, this is a top-down project. And what's the project called again? Well, the project is called the LHWP, the Lesotho Highlands Water Project. So that would be our first sentence. And then you would go ahead then and communicate your ideas clearly and logically. Well, what it is, we need to look at the social, economic, environmental impacts that it's having. We need to use facts and figures that we've remembered, and also geographical terms. So water deficit, for example, water scarcity, water surplus in the mountainous regions. Use the word sustainability, and then an accurate spelling, punctuation, and grammar. Now, if you would like to go ahead and give yourselves 10 minutes to answer this question. Okay, maybe having had answered the question, you feel that you would like to give yourself a score out of 8. This would probably be generally what would be used. So level 4 being the highest, the band 4 provides a balanced account, elaborate description and explanations specific to the place or scheme, communicated communicated very clear, sophisticated and structured. Specialized terms used adeptly. Spelling, punctuation and grammar has been consistently accurate. Or maybe possibly you feel that communication is clear, logical, the structure, but possibly not reaching the 7 to 8 marks. Maybe there's less facts and figures, and maybe there's less specialist terms used and communication, but it's still clear and logical. Maybe you fall into 3 or 4, or possibly it's generic and it's more descriptive and there's little facts and figures. This would fall into 1 or 2. So think about where you would probably sit having answered this. Okay, next then, are there alternative ways to manage South Africa's water? Well, South Africa has 539 large dams, which is almost half of all of the dams that they have in Africa. But despite this, there are still a large number of South Africans without the access to clean drinking water, especially in rural areas. Many of these people live in rural areas from parts of South Africa, are too isolated to become parts of the big projects like the LHWP. They're too poor to drill boreholes, so to drill into the aquifers, to tap into groundwater supplies. Instead, they have to rely on cheap, small-scale methods of rainwater harvesting. So strategies in the developing world, such as non-governmental organizations, such as water aid, often develop small-scale and sustainable strategies to manage water problems in lower-income countries. We call these intermediate technology, and they must be suitable for the area and self-sufficient to the people that live there. 60 million children are born each year in developing countries, and they don't actually have access to safe drinking water. So these bottom-up strategies, we've looked at top-down, these are bottom-up, going straight to the people instead of coming from the government. So rules for intermediate technologies, as you can see here on the left, they need to fit in with the climate of the area. They're going to be low cost. They need to be within a technical ability of the local community. So they need to understand how this works. They use local materials. They're close to a village or where there is a population. They can be easily repaired if it is to break. Make sure that local people are involved in the process so they know what to do and they have a say in these intermediate technologies, and they provide training so that local people know how to use this resource. For example, the one that is seen in the picture. So one example would be sustainable water management on a small farm. So this one farmer, South African farmer, teaches rainwater harvesting techniques. Management strategies are affordable and practical for families, no matter how small the farm is or how little money they have. They use ways that are cheap, practical, and easy, and more importantly, sustainable. For example, by collecting water from the roof of a farm. They benefit people not now without doing any lasting damage to the environment or using up valuable resources, unlike a big dam building scheme used by governments. So these can be done through water collection tanks, and they call them pumpkin tanks. So why do they call them pumpkin tanks? How do you think they work? What can communities use water for? So if you want to go online and research what are these pumpkin tanks, go ahead, and they actually used by Water Aid in a bid to conserve water for people. And you can also have a look why you think that they're sustainable. One other reason or method of getting water, especially in developing countries, is through boreholes, as I mentioned, or aquifers, and abstraction of aquifers. And as we can see here, it's the taking of the groundwater beneath the bedrock. Now, as I mentioned, in terms of rainwater harvesting for South Africa, they had also done this through fog, and they have provided clean drinking water to isolated rural communities since 1987. That is also set up in Chile. It is another form of appropriate technology because it is relatively cheap to install and maintain. To collect water from fog, a simple system of a fine mesh nylon net, and they're suspended vertically between tall poles. The fog condenses on the net and drips in a gutter below. Fog harvesting works best in upland regions. As we know, that's where the most rainfall is, above 400 meters above sea level, that experience moist air being blown from the coast. As the air rises, it condenses to form fog. However, thinking more about aquifers, boreholes, and abstraction, well, this happened in India, and we're going to look at why in northwest India this happens most. So some layers of porous rock, known as aquifers, store huge quantities of water under the ground. Water from rain and melting snow percolates down into the ground where it's stored. This process is known as a recharge. To use this water, all we have to do is dig or drill into the ground, and the water can be abstracted. The abstraction of water from the ground is a major source of water supply in India. In fact, groundwater provides 65% of all water used in agriculture and 85% of domestic supply. That's crazy, just from aquifers beneath the surface. But in some areas, over-abstraction is taking place. This is when water is taken from the ground faster than it is being recharged by natural processes. So that the rainwater isn't refilling the aquifer, and the water is being over-abstracted, and it's not being filled again. So it essentially no more water can be taken. In many places, the water table is 4 meters lower than it was in 2002. There are concerns that as demand of water in India continues to increase, shortages will be more common. Well, why is so much water abstracted in India? Well, there are 6 reasons towards this. Seasonal rainfall patterns, and I've said, like states in the northwest, Gujarat, having a long dry season, surface stores such as lakes and rivers can be dry, so they will have to use and rely on abstraction from boreholes. Surface stores are often polluted by human waste. Groundwater is considered a lot cleaner, although groundwater can be also polluted, especially with pesticides from farms. Urban water supplies are poor. Many people buy water from water vendors, still at very high prices. Drilling a well is seen as a cheaper method in the long term. Indian government has encouraged farmers to grow more food to feed the growing population, as well as this green revolution has used crops that tend to need more water than traditional crops. So again, they sort of encourage the use of, well, we need more water, and this can be done through abstraction. Cheap electricity has encouraged farmers to drill very deep wells to install pumps to extract the water. The water table falls and the wells of neighbouring farms will dry out, so they have to drill even deeper. And this is going to lead to further problems in the future. India's monsoon rainfall is unpredictable. In seasons with lower than average rainfall, like in 2012, the aquifers were not fully recharged, and there was actually water scarcity thereafter. And again, they had to drill even further deeper in order to get any water. Who should solve this problem? Well, Indian government could borrow money to build even more dams for clean access and cleaner water. This type of project is known as top-down, as we know this, whereby big decisions are made by public officials. However, dam construction has sometimes been very unpopular in India. So in terms of solving the issue, non-governmental organizations are largely doing this in India. However, it's possible a question that the government then steps in to influence and change how water demand can be controlled. So a possible exam question then you could look at, using one example you've studied, explain the consequences and control of water over extraction. So you can use the example that we've used of over extraction and look at some of the consequences, sorry, not results, consequences. So a social consequence, an environmental consequence, and an economic consequence, and then possibly how they could manage or overcome the problems in this circumstance. So if you'd like to pause the video here and go ahead and answer this 6-mark question using the example that we've used here. Great. Well, that's everything for today and this session on water resources and use. Hopefully this has benefited you in some way. If you do have any questions, please do not hesitate to send me an email, either of which or both of use. If not, I will see you on the next sessions that are all available on the Carlam Cymru website. Diolch yn fawr. Thank you very much.